Yes, it is. Okay, so I've been asked to make a video about what to do when you're doing problems like this, and I've been really hesitant to come up with a formula or to give you like an algorithm necessarily, because I think that it's the better policy is just to think through each problem individually to figure it out. It's really not all that complicated, but let's just categorize these sorts of things. And in particular, the question is what happens when you don't just add or subtract 2 pi to whatever problem, whatever angle you're given. And so I've got a series here, and the thing is that what happens differs depending on which function we're talking about. So let's just deal with them. We'll just deal with each category. So if you end up with something that's up in this first quadrant, I'm going to assume that you're going to be okay. For example, if you're doing the sine of the inverse sine, wait, is that the, no, sorry. The inverse sine of something like, should have thought of something ahead of time, I guess. How about 9 pi over 4? So you have this angle. 9 pi over 4 is, you go a full circle, which is 8 pi over 4, and then you go a little further. You're up here in this sweet spot where everything is good and all the kids are happy. And so up there, you're not going to have any problem. When you're in quadrant one is the happy quadrant. So quadrant 1, that's happy. You do whatever, you do what you expect, and that is, it's just going to be whatever angle is right here. In this case, it's pi over 4, and so that'll be pi over 4, and we're all happy. So where things get funky is when you get into these other quadrants, because the difficulty is that it differs depending on the trig function that you're dealing with. So let's just do a quick reminder here of the, oh no, I erased too much. Let's see, can I just erase that? Yes. So up here, so let's remind ourselves of what exactly is going on in these quadrants. Here, everything is going to be positive. Everything is positive. And then here is just the sine, here it's just a tangent, and here it's just a cosine. So this kind of spells out in reverse the word acts, but however you can remember that'll help you. So we've got that situation, and then you've got the situation that the tangent and the sine are going to be, let's see, can I do this color-wise? It's going to be hard. So in terms of the inverse tangent and the inverse sine, we're dealing with the first and fourth quadrant. Maybe I'll use the highlighter. Here we go. So over here, this stuff is that's the range of values for the inverse sine and the inverse tangent. I wish this had been a little thicker. Oh, there it goes. That's good enough. Okay, so that's the range of the inverse sine and the inverse tangent. So it's this, this problem where there's not consistency, if you will, up here with the arc cosine in particular, that makes it difficult to have a hard, fast rule, because once you think you've got a rule, you're going to have exceptions. But up here, so let's go ahead. I'll try to highlight this relatively quickly. Highlight. Up there, that is the range of the arc cosine. So this is the range of the arc cosine. It's right there. Okay, so like I said, I'm going to do my best to help you out with this, and we'll do these one at a time. So I've got all three of these angles. They're all, by the way, all of these angles are familiar, but looking up here, this top one, these three problems all deal with the same angle, but the way that we're going to deal with them is a little bit different from one another. So let's go ahead and draw this angle in. This is a familiar angle. It's not going to be a big problem. So it's not like it's 3 pi over 7, but nonetheless, we're going to treat it the same as if it were 3 pi. Well, 3 pi over 7 wouldn't be up in that, more like 5 pi over 7. So you've got this angle. So here's the key, is that up there, the sine of this thing, so now we're just looking at the inside here. So this part right here, whoops, there, that box. So that the sine is going to be positive, tangent will be negative, and cosine will be negative. Okay, so this is going to affect where the image, the inverse, is going to be. You see, the sine is positive up there with this angle. And so what's going to happen is that the output of that first one, that output, is actually going to be up here in quadrant 1, because that's where the sine is positive. And so we just have to find an angle that has the same, here I'll just put this in here, the same reference angle, and that's going to be this one right here. So sine, since the sine is positive, it goes up into quadrant 1, so Q1, which is going to be just pi over 4. Let's skip down to the tangent. The tangent is negative, and because, see, the range of the sine and the tangent are both on the right-hand side of this. So because the tangent is negative, I need to shove this thing down here into this quadrant. It's going to have that same reference angle, though. So I need to know what angle is going to have that reference angle and be down there. And so that's going to be negative pi over 4. Finally, with cosine, cosine's the easy one, because this angle, 3 pi over 4, actually is in that blue highlighted, if you can see it, the range of the inverse cosine. So because of that, really you don't have to do anything. You just get 3 pi over 4. So that one was the easy one. Okay, so that's the sort of thinking that you do when you're up in quadrant 2. Any angle up there, no matter how many times you're going around the circle, you find your reference angle. The reference angle is this angle in here, and then you go from there, depending on if you're doing the sine, cosine, or tangent. Okay, now we'll move down to quadrant 3. So here's just one example of an angle that ends up in quadrant 3. Let me erase some of this. That's going to be hard to erase. Without erasing everything, let's see what happens. Yeah, I guess I can erase that. Maybe if I can be selective, if I'm careful about where I'm erasing. I got rid of the wrong thing. Yeah, I don't think, because the highlight, it prioritizes getting rid of highlights. Well, it's all going to go away. Sorry. That's okay. Yeah, you can always back up the video if you need that highlighting. Okay, so this angle is negative 5 pi over 6. It looks like this. The important thing is that it is in the third quadrant, and you can compute its reference angle. The reference angle here is pi over 6. Always the reference angle is terminal side up to the x-axis. So whatever you need to do to figure that out. In this case, I think to myself that if this angle were continuing all the way to the x-axis, it would be negative pi. And so the little chunk that I would need to go to get to there is pi over 6. So 5 pi over 6 plus pi over 6 is 6 pi over 6. Okay, so now let's see. Tangent is the positive one here, so let's deal with that one first. Since tangent is positive, then basically anytime you have your, and you'll see me do this in the fourth quadrant as well, anytime your angle is positive, that is, you're in a quadrant where the sine or the cosine is positive, then you're just going to push this into the first quadrant. And essentially, you end up with the reference angle. So in each case, like if you're doing sine, if you're in the second quadrant, the sine will be easy. You just push it into you just use the reference angle. Here, the tangent is the easy one, because this ends up just being the reference angle, because I need to know what angle has a tangent that is the same as this angle, but is in the first quadrant, and that's just going to be that reference angle. Okay, so next easy one is the sine. The sine is negative down here in this quadrant. So the sine of this angle will be negative. So I need to think, where is the arc sine negative? And if the highlighting was still here, you'd see that everything to the right would be highlighted for inverse sine or arc sine. Inverse sine is positive. The angles are positive above the x-axis, negative below the x-axis. And so I need this angle down here. And that's going to be negative pi over 6. That will be the inverse. Oh, wrong one. Let me move that to the proper location. The inverse sine of the sine of 5. So that angle has the same sign as this negative 5 pi over 6. Finally, the cosine. The cosine is difficult because it's the oddball. So the range of values for the inverse cosine is going to be up here. So I had those highlighted before. First quadrant is where the cosine is positive. Second quadrant is where the cosine is negative. So this particular angle, negative 5 pi over 6, has a negative cosine. And so when I do the inverse cosine of the cosine of that angle, I'm going to end up in the second quadrant, so up here, with the same reference angle. So we have to actually do some thinking here. And that means that we'll just have to figure out what that angle is, but that's not too bad because we kind of have the mirror image down there. But the whole half circle would be pi. Subtract pi over 6 from pi, and you get 5 pi over 6. That'll be the answer to this. So you can see, I think even now, like I said, I was going to give you a rule or an algorithm, but there isn't really a rule. There isn't really an algorithm you can follow. Probably I could divide this into a set of 20 or 30 different cases, and you just fit it into the right case. But who wants to memorize all those cases? Just draw the picture and get the job done that way. Okay, last one is the, is going to be something in the fourth quadrant. So I have my example angle. Let's see if I can erase. I'll just leave that there. As long as I don't, oh well. I was trying to avoid hitting. Okay, so as before, 5 pi over 3, we're going to draw the angle. Draw the angle. So we've got 5 pi over 3 is right about there. 6 pi over 3 would be a full circle, which means that this piece here that we're missing, so this is, I don't want to put that there. We'll just remember that it's 5 pi over 3. So that chunk, that reference angle is pi over 3. So what are we doing here? Let's see. The cosine is positive, so the cosine is, you're just going to take that reference angle. So you're in the domain, the place where the cosine is king, if you will. So since the cosine is positive down there, the arc cosine will be just in this up here. I can draw that. That's going to be pi over 3. Now we have to deal with these other two. Tangent and sine are going to be the same reasoning, so we'll just do it once for the sine, and then we'll deal with the tangent. So both tangent and sine will be negative down here in the fourth quadrant, which means that the arc sine and the arc tangent, for that matter, will put the angle into where the arc sine and arc tangent are negative. And so, first of all, the range of values for arc sine, okay, that got kind of weird. So this range is over here, first and fourth quadrant. So the sine and tangent are both positive in the top and negative down here. And so to do both of those, I'm just going to figure out what angle do I need? And it's going to have the same reference angle, so it's going to be exactly the same angle there. And I just need to figure out how to write that in the way that the arcsine and arctangent will be happy. And the way that those will be happy is to write that as negative pi over 3. So that's what that'll be. Well, I hope talking through these is helpful. If you would like me to make yet another video on this subject, give me some angles. Tell me like, oh, I need help with this particular angle, 5 pi over 7, or whatever it is, and I'll do my best to accommodate you.